So, oh, too loud. Poison, but let's start before I talk about poison. When you need to, in Elixir, normally, when you need to do JSON parsing, normally what we use, oh, it's not working, let's see. No. Sorry. Oh. Cool. So normally what we use, a library JSON. Who here uses JSON for parsing? Because normally the main reason, I think, is because it's fast, right? That's the main reason we use JSON instead of Poison. If you see, it's not to work again. Oh, no, I see. I think that's why it's used for another libraries like Postgres and Ecto and Plugin Phoenix, Absinto. Okay. This is the basic usage. So if you need to encode a map to a JSON, use encode and the code function the inverse way, receive a JSON string and then transform in a map. But you have Poison. And we don't use Poison because JSON is faster, is better. Okay. The usage is similar. Encode, decode, have another functions. But there are some difference between JSON and Poison. This is from the JSON documentation. I will not go to details here, but one specific that I will talk about today is about no support for decoding into data structures, the S option. So what does it mean? If you see the usage of the Poison, it's possible to decode a JSON string directly to a structure, and then you pass this option as person, in this case the person structure, and then you decode instead of the result, instead of a bare map, you are decoding directly to a structure. That's cool, works. But in general, when you are decoding a JSON, imagine that situation, you are consuming an API and you have the response from the API, a JSON API. In general, this response is not, we have a complex data structure that you have many levels, and then if you do that with your JSON response, transform it that way in a structure, we can only decode the first level. We cannot go nested. So in a practical way, this doesn't work very well. This is a thread from the Elixir forum. It's an old one that one guy asking, okay, how can I do that? I have this JSON and I have nested objects that I want you to transform the top level and the nested states. That's the second structure. If you do that, I don't know if you can see, okay, but the last line is using the S top level as an option. And the best answer that this thread received, first decode the top level and manually go to the nested levels. This is not useful if you have many levels, so you cannot, it's not useful. How can I solve that in a better way? I will show you a real code, an example of a real code. I know that you cannot see, so I will show the first part of this code. This is a Elixir structure that represents a JSON response for an API. In this case, we are using type structure, but don't worry about that. Imagine that is a standard Elixir structure. And here in the definition on the bottom, we have the fields, the attributes for this structure, custom fields that at the end is a map, email, locale, they are strings, and then you have reservations, the attribute reservations. And the reservations is a list of another structure, reservations, okay? In this structure, reservation, it's another complex structure, have a bunch of fields, and one of these fields is another list for sorry guys, let's go to the, okay. So we have the itinerary structure that has a field, reservations, that's a list of reservations structure. And then here, the reservation structure, a bunch of fields, and two of them are lists. One is a line item, another nested structure, line item, and another one is room that maps to the reservation room structure. Just quickly show here. This side, the reservation room, is a normal structure, and here the line item. Okay. So, how can you do that? How can you decode the entire nested for all the levels? So, going back to the previous itinerary response, I will show the another part of the code. Here we have a function called the parse bank that receives a JSON, a string, a JSON, and then we use Poison the code bank, passing the JSON, the string, with the S as an option, and not only pass. In this case, the model is the same in response. That is the top level structure, but then I can pass reservations as an attribute and map the reservation as a structure reservation, and the same for all the nested levels. And then I can map with this option in Poison what I want to decode, the way that I want to decode. And moreover, you see here in the line item, I have one field that I want to be decimal. But I receive, on the JSON response, I receive this amount field as a string, and but I want to use in my logic, in my structure as a decimal. So what I can do, I can implement the Poison decoder protocol, and with the function decode, I do any transformation that I want. In this case, I am transforming the string amount in the decimal and assign it to the amount field. So here I have the flexibility to do any transformation that I want with any type, any function. So I have this flexibility. This is one example of this structure that I showed to you to the code. So this is the JSON. We have the reservations on the top, the rooms, this list, and line items. I know that the font size is not good to see, but trust me, they are there. And then this is the output. I split into parts to make it a little better to view, but we have the itinerary structure and then the reservation. That's a list of reservation structure, and the same in the line item. You see that the amount is decoded as a decimal, not as a string, because we implemented the protocol and did the transformation. So basically is that. If you look again, this is the trick. In fact, if you go to the Poison documentation, it's not documented, and I don't know if you guys are already using that, to know about that. This was useful for me, or useful for my team, and I just want to share with you. I hope that you'll be useful as well. I am Fernando Hamazaki de Amorim. I work at Finatel. Finatel loves Elixir, and we are hiring. Thank you.
Thanks, Fernando. Francisco, could you go to Barbara there at the desk and sort out, slide decks, format, whatever you need for your lightning talk. And in the meantime, Carolyn from YOLO has a couple of words and I think a giveaway.
Good evening, everyone. So the first conference day is almost over, so time to give away something sweet. I'm Caroline from YOLO Group, formerly Going Gaming. So can you please raise hands who actually visited Going Gaming or YOLO Group today, booth today? Okay, really good, really good. So I hope you signed up for the lottery as well. So we're actually giving away 3 pair of AirPods and a trip to Tallinn. So today we're going to start off with this 1 pair of AirPods. So if you didn't sign up yet, you can still fix that little issue and come back after this presentation. But anyways, so also if you want to hear why we transformed from Going Gaming to YOLO, then this is also an interesting story, so come by. But as YOLO says, then you only live once, so let's not spend any more time. So I'm going to announce the winner for this pair of AirPods, and this is Piotr Ponichtera. Are you here? Does anyone know that guy? Okay, let's wait up. So how was today? Good? Really good. Ready for the party? So Piotr keeps people waiting. Come on stage. I have a little something for you. So happy you spent time in our booth today and signed up. So congratulations for winning. You want to say something?
Thank you, everybody.
Thank you. So come visit us, and some new prizes going out tomorrow. Thank you.
Francisco, are you in fact here? I guess you're not. Okay, so we can move on to Ivan, who is online. We're not quite ready yet.
Oh yes.
We're ready? Okay. Ivan, the stage is yours.
Thanks a lot. It's a big pleasure to participate in ElixirConf, even virtually. So I'm sharing my screen now. And my talk today is about DOMO library. So I hope you see my screen now. So yeah, give me a sign if it's visible, please. Alrighty, thanks a lot. So DOMO library, basically, what are the sources of invalid state of the application or a group of microservices representing a domain model? Usually it can be a network input, it can be a database and file input, or it can be application state itself due to logical errors. And so how it can be addressed? Well, basically the application state, usually it's struct in many cases. And the question can be how to check that the state struct is valid. So for example, it can be a declaration, a schema with a type spec for the struct. It can be sharing of these types for consistency between various applications. It can be a declaration of value range precondition functions for the types. And it can be a function to validate struct data matching the defined type spec. So the Domo library gives tools for exactly that. At compiles time, it gathers struct type specs across the project and library modules via custom compiler. It seeks precondition functions to the types for value range checks, as you see in this example. And it supports custom error messages from precondition functions. And it, what is especially cool, validates struct default values at compile time. So at runtime, Domo adds the following functions to the structure that basically leaves the same functionality at runtime. It integrates to Acto for change set validation. It supports precondition functions for type to validate struct value as a whole to fulfill domain model invariants. So let me show a small demo now. So basically, here we have a here we have a website with two Phoenix contexts for boardings and cargo. Each of them backed by separate Acto repo. So to make these two contexts extracted to two separate applications easily. The only common thing here is the shared type definitions. So for example, I can board a passenger, and if I enter the incorrect flight number, adding the fifth digit there, then I get the appropriate error given by the taken from the appropriate precondition function. So how can we make 5 digits supported? I open the shared kernel module that shares the flight number type, and I can basically extend the precondition functions in the following way and changing the error message like that. So, and going back to the web application, I can add passenger again, and after Phoenix hot reload completes, it's successfully added. So I can do the same in cargo service because the type definition is shared. So I can add, for example, 20 kilos cargo. Okay, sorry. And it says that this should be of this format. Okay, let's make it correct. So now I can have commercial cargo and passenger baggage as a shipment, and I have various kind of measurements here. So how can I limit only for these kind of units to commercial cargo and kilograms to passenger baggage to make it like a domain constraint here? So I can go to the code and open the shipment schema. And here I uncomment this precondition function for the T type as a whole. That basically validates if this commercial cargo and kind of unit measurement, then it's okay. Otherwise, it would be an error. And if it's a passenger baggage shipment kind and a kilogram measurement, that it would be okay. Otherwise, an error. So let's go back. And now if I edit again, it would say, no, you should have only appropriate measurements here, boxes. So I can select box, for example, 2 boxes, and now it works. And the same for passenger baggage. Here I should add the place. And if I try it now, it says wrong. And if I say kilograms, then it works. So basically, Domo is a tool to keep model consistency across applications and microservices by sharing constraints declared with type specs and attached precondition functions. It ensures that incoming data from network database file and application's tail is within constraints and compile and runtime. It supports Phoenix hot reload and integrates with Ecto. To find more information, you can follow these links. Thanks a lot. So, please, questions.
Stefan? Great. Do you want the headset, or are you okay with this?
Oh.
Okay. Anything else you need?
All right, thanks a lot.
Okay, hi. So my name is Stefan Chrobot, and I want to show you how we test every aspect of an HTTP request, and why do we even want to do that in hopefully under 5 minutes. So you have your SaaS application, which is already pure gold, but then you're getting tasked with adding more integration to that app. So you need to pull your customers' data from external systems, and let's say that your customers have their contacts in HubSpot, and some other customers have their contacts in Salesforce, and somebody else is also using some other system for that. And for a moment, you're considering building that yourself, but then you think about all the maintenance costs, and that's when we come in. So I work at XKit, and our elevator pitch is basically add an integration to your app in 1 day, right? And we do that, and we build our system in Elixir. So if you were to use us, we would sit between you and your customers' apps, and we would talk to the external providers via HTTP and handle also the authorization aspect for you. And in this setup, you would most likely use auth to get access to this external apps, which is this pop-ups that asks you, hey, do you want to let app X access your Google Calendar or whatnot? And then it's like allow, deny, right? Auth has a bunch of RFCs, but it's like really not a standard. It's like a framework, which basically means that everybody does it slightly differently. But at the end of the day, you get a short-lived access token, which you need to periodically refresh for security reasons. The important thing there is that you should never mess it up, because losing the refresh token is pretty bad in terms of like a user experience, because the data will stop flowing into the system, and the user has to intervene and reauthorize your app manually, which is like really bad. So it's really crucial for us to test every aspect of the authorization request, and to make sure that we get all the details of the HTTP request right. So let me show you how we make this happen. So we use Tesla as our HTTP library, because it's like feature packed. It has like pluggable features like JSON encoding, decoding, logging, retries, and whatnot. But it also like lets you swap the low level, let's say, they call it like an adapter, but it's really the HTTP client that's like underneath it. So it's like Hackney, Mint, or whatever you want to bring. So you can extend Tesla with your own stuff. You can roll your own stuff. And we do exactly that, right? So in the dev build of our application, which basically is like the mix and thing, we use a wrapper adapter. And every time you make an HTTP request, we dump 2 files to disk. We name them like with a timestamp and like a unique ID. And the dumping is pretty straightforward. Let me just enlarge my screen here. Yeah, so basically we take the like usual adapter that you would use like for Hackney or whatnot, and we wrap it with our own custom adapter, which does a pretty straightforward thing. It takes the data structure that represent the request and the response and uses the inspect protocol and dumps it to a file, right? So Tesla is pretty cool because it uses behaviors, and like writing your own adapter is just like a matter of writing a call/to function, which is pretty straightforward if you're just wrapping something else, right? So the dumped request looks like this. It's exactly the tesla.env struct, which represents the request and response, both of those things in one data structure. So we dump it right before we pass it to the underlying adapter, and we also dump it right after it comes back from the adapter. So you can see that the initial one only has the URL that I'm asking for the ElixirConf.eu page, and when it's coming back, I have like the body, the status, and whatnot, and the headers, and I kind of truncated the not important parts. So then we would take this pair of request and response, we would tweak it as needed, maybe kind of replace the real credentials with some fake credentials, and then use these 2 files as a test fixture. And then in the test build, which means in the tests, we would swap the adapter that is used by Tesla again to something else, and we would use like a mock HTTP adapter. We think that like using mocks is a better choice than using a built-in Tesla mock adapter. It has one, but I think like it's a better way to kind of test Tesla-based apps using like mocks due to the fact that there are those nice behaviors that you can use. So we do that. So we plug in the mock adapter, and then we have like a small hand-rolled helper that just kind of stabs this mock adapter with like those pre-recorded requests and responses. So we just read the file, set up the expectations on the mock, and then just compare the incoming env against what we have recorded, and if it's fine, then it's fine. If it's not, then we raise an error. Hey, this is what you gave me, and I expected something else, right? And then the tests are like super simple, so I can write a simple test. At the beginning of the test, I would just say, hey, these are the requests that I'm expecting, and then I'm just kind of free to make any HTTP call that I want, right? And I can like make assertions on what's coming back from like an HTTP call. I can check the status that I'm kind of getting redirected. And that's pretty much all, and it makes us really happy because it allows us to make and have like concurrent, fast, and repeatable tests, which obviously adds over 9,000 points to confidence. And so this is like an output of our test suite. So if you're doing something similar in this space and you're kind of approaching this similarly or even more like totally different, I'd love to hear back from you. Thanks.
Okay, thanks, Stefan. Radek, you're up next, and we're going to need some time to set up.
Czy nie działa? Działa? Chyba działa. Tam w view po prawej nie da się? Okej, jest dobrze, wydaje mi się. Myślę, że jest spoko.
Okay, so here's Radek with type checking Elixir.
Thank you. So there will be no slides, just the editor and the Elixir shell. And I'm super excited to be here, so you might hear that in my voice. I hope not too much. As Sasha Juric pointed out in his keynote today, clarity is super important in our source code, as it's a means of communication between people too, not just a person and the machine. So I will try to use types to give some more clarity to the message passing API of our processes in Elixir. And I think that Dialyzer has paved the way to use types and specs in the Erlang and Elixir ecosystem. But sometimes we feel that it's a bit clunky. So maybe we can use the types and specs to give us more feedback and more information about our code, and also to communicate more clearly to other people. So on the left-hand side, I have a demo module, a demo gen server, which uses some type and spec annotations. And what I want to do is to declare that this gen server is going to accept messages of this type. So a contract echo request and a contract hello request. And I'm going to use a tool called Gradualizer that is developed by Josef Svenningsson, and that I together with Przemek Wojtasik, a colleague from the Erlang Solutions office in Krakow, have developed to make it possible to use Gradualizer with Elixir, because Gradualizer is originally an Erlang tool. So I have an Elixir shell running on the right. I'll copy this snippet, and let's see what we have when we run it on this module. So far, so good. It's OK. So let's go step by step and change this definition not to include contract hello request. There's only one request in the type right now. Let's rerun this and see what we get. And it says that on line 62, there is a clause that cannot be reached. So let's check line 62 and see what that is. It's a handle function clause for a message of with the hello tag. So OK, we do not declare this kind of request in our type now. And we get a warning that this clause is basically dead code. So OK, let's remove that, or at least comment it out. And let's see what happens now. Good, back to normal. So let's see when we change the type definition to the original one, the one we started with. And run the type checker again on that. And we get feedback that we have non-exhaustive patterns on line 56. So this type checker gives us exhaustiveness checking, like in languages like Elm or Haskell or PureScript. So these statically typed programming languages that we know. And we also get an example value that we are not handling the hello type of message. That's in Erlang syntax for now, but all of this is pretty experimental. So bits like this are not yet handled completely properly. So let's implement this function again, and let's see what we get. OK, back to normal, all good. So we get feedback for dead code, and we get feedback for missing implementations. What else can we get from this? For example, let's say I was sloppy implementing one of the handlers, and I made a typo in the message tag. Let's see how that looks. The pattern, blah, blah, on line 56 doesn't have the type message. And indeed, it doesn't. It wouldn't match at runtime, but we get this feedback now at check time. So OK, let's fix that. And again, back to normal. Everything is fine. So, so far, we have looked at the request handling side of the Gen server. And we do get some useful information from Gradualizer about the state of our code in the context of what we declare about our code. So can we do something on the other end? Like, can we use Gradualizer to help us with the responses that we get from the Gen server? And yes, we can to some extent. But it's important to note at this point that Gen server call has this type signature. So the thing it returns is just a term. That's the most general type for anything that we might type in Elixir. So in order to let Gradualizer help us, we have to help it and provide some more type information. And this is something that we do with a macro call like annotate type. So we do our usual Gen server call with the PID of the process, with the specific request type, but then we provide the type of the response for this request. And Gradualizer does not type check message passing itself. So this little thing, this part is on us, on me as a programmer, to know that for this request, it's this type that's going to be returned. And thanks to that, we can then use Gradualizer in this case statement and rely on this exhaustiveness checking. So if this type, if this echo result type had more clauses, had more variants, we could type check on that, and we would get the warning that, hey, you're not implementing a clause for this variant. We can also rely on it to check if the message tags are correct. So if we do a silly mistake like this again, we will get some feedback on that. And there's one more way to specify the type of such a message. So if this feels too heavyweight in this particular line, if the annotate type macro is not something that we like, we can provide this information by defining an external function. So this is completely equivalent to Gradualizer, and it will also allow us to type check this code. So we can see that by using type specs and by using Gradualizer, we can get important feedback about our code, and we can improve the clarity of the message passing interface of our processes, and get this feedback way sooner than after running a CI build or running the test, because we get that at compile time. We can also see that Gradualizer type checks way faster than Dialyzer does, so this is also an well, a good point. And Kevin Hoffman, having a talk in the other room about using WASM and Rust and Elixir, said that people used to strong and static typing, for example, with a Rust background, are kind of are freaked out about programming in Elixir because of no the lack of the safety net of types. So using techniques like this, we can recover this safety network, but we don't have to use that in every place. We can quite gradually or quite fluently switch between completely dynamically typed code and code which uses type specs when we need this extra level of confidence. And that's what I wanted to share with you today. If you're interested in this approach, you can check out this example on GitHub. The link is on the bottom right. Or you can send me a message with some feedback about this on Twitter or via email. That's it, and thank you.
Thanks, Radek. So Carlo is up next with Kiss Your Testing Framework, as in keep it simple, stupid. Do you want?
I don't remember the thing. Okay. That's it. That's it. They can hear me? Okay. This will be really quick. So I'm Carlo from Zagreb, working for YOLO. As in everything in your code, you need to kiss your testing framework. How did I this wrong? So who came to Elixir from Ruby world? Oh, and everybody loves RSpec, am I correct? I was in love with RSpec. But RSpec is DSL, and Sasha said DSL very bad. Then I said, OK, I will write my Phoenix. My first Elixir application. I want to use ESpec, which is like port. I mean, a lot of writing very good Phoenix Elixir code. It mimics RSpec. Basically, you have something like this. You will all remember that, hopefully remember from Ruby world context, it, expect, a lot of functions, and everything was fine until I hit import Phoenix live view test. And there was no support in ESpec for that. So I have something like this. You see a lot of ESpec folder with a lot of tests. And now I need to have here test, which is live view test. So keep it simple. XUnit is excellent framework. It's written by future developer of cool features, like probably Phoenix Live View X. So XUnit has, I didn't do my research. It has everything that RSpec and ESpec has. So you don't need anything from ESpec, from the XUnit. Keep it simple. If you need to install something, that something needs to be keep it like up to date, which is not so much in case with aspect. And that's it from my side. Thank you very much.
Is this on? Thank you, Carlo. So Zach, you're up next. And Zach's title is Enumerable XML with, hopefully I'm pronouncing it correctly, Yakety Sax? Is it Yakety Sax?
It is Yakety.
Okay.
Okay. Woohoo! All right. Let's do all that. Yeah. I don't have much open. Cool. So yeah. What was the name of it? The name of my talk? The name of my talk was Enumerable XML with Yakety Sax. Okay. Good. Yeah. Yakety Sax is this. I talked about it actually about 2 years ago in Berlin at a lightning talk. I don't know. It was about 7 days old at the time. Then I just put it on the shelf, and 2 months ago finished it up a little bit. And was thinking today, I know this crowd just loves XML, like that's really the thing that everyone is really here for is the XML. So I would talk about that to make, everyone's day. Parsing XML is probably like the least fun thing you can do, or handling XML, be it with a DOM parser that eats all your memory, or if it's with a Sax parser that you have one single function that gets to handle everything. That's no fun. So I wanted to get away from that and built this, and it's a pull parser. So essentially you have an iterator state, and you say, give me the next thing, and it gives you the next thing. You have a new state. You can hold it. You can pass it. You can pass it to another process. Do whatever you want with it. You're not linked to that one module. And I thought, that's kind of a cool thing. And this is, by the way, it's for Beam languages because it's written in Erlang. So, but this is all about Elixir and XML, right? So I thought, maybe it's pretty cool. I could make like an enumerable out of an XML stream. Maybe I can do it. So this morning I started working on that. And yeah, what did I get? I got, well, something that's using Yakety Sax. And everyone can, is it too small? Yeah. And that's a suck font for this. Okay. Either way, implemented enumerable over this state thing, pretty simple. The only thing it actually really does is called next event when it can. So cool. Now I thought, okay, I just want to show this off a little bit. Let's make a stream out of it. So here we go. We're going to make our parser state, and then filter it just for the character events, and those are just the text events. And then reject everything that's completely white space. They're tagged, the events come back. If it's a white space event or not, they're tagged. I'd like to take the first million, because the file I'm about to hit is 17 gigabytes. It comes from Wikipedia dump, and it's the dump of the comments people give when they do edits in Wikipedia, which means it's full of nastiness. I mean, really like hate speech. It's very bad. So I'm not going to print the text. I just want to see how much, and I want to see how many of those things are marked with the word vandalism somehow inside, because people vandalize Wiki nonstop, and it's actually kind of funny, but it's also not funny. So we're just going to count how many out of the first million are vandalized, or at least have been marked as vandalized. And yeah, this is really only a portion of the wiki dump. It's 17 gigs when it's open. The full one for this is 69 gigs when it's gzipped, so I don't want to know how big it is. XML zips down to like 1 to 100 or something, so yeah. Yeah, so let's try it out. Oh, and if anybody wants to know about the name, Zap Zap, why'd I call it Zap Zap? It's because it's a lightning talk and like Zap Zap. And then why is the only function named Pow? Because Zap Zap Pow is pretty cool, so. Let's do it. It takes a little bit. Cool. So 3,395 vandalized comments out of the first million. Now this document probably has about 100 million comments in it. It's a lot of vandalism. And another kind of neat thing, let's see. Oops. Let's see. A fun little aspect about pull parsers, and especially this one here, is that they attempt to be zero copy. Now here it won't, maybe it won't work because you have UTF-8 and you might have a break in your stream. You do have to eventually make your own binaries, and also when you're saying, "Ooh, I've got this, ampersand AMP semicolon," that has to be rewritten to an ampersand. So those things do get fixed, and there is a copy, so it's not perfect. But let's run that again and see what's going on. Like for memory, nothing is going on. It's just flat. So that's kind of unique among the XML parsers, I think, is that they don't mess with you. And this one just used its CPU that it was on because it was in a single process running its stream. And that's it. That's all I got.
Okay, thanks, Zach. So that was our last lightning talk. Quick reminder, party, I think just outside, and you should have gotten coupons sort of when you arrived and probably a couple of minutes ago as well with the remaining coupons. Yeah, so that's it, folks, for today at least. Yeah, virtual attendees, you can find us on Toucan. Yeah, thanks everyone. See you outside.